Okay, here are some homework questions related to the IJ questions that I gave you from the textbook. So pause the video here, check that these are right. I'm going to go straight on. Here, you were asked to show that the magnitude of x plus the magnitude of y is greater than the magnitude of x plus y. So the first line there, you get the magnitude of x, second line, magnitude of y. Get those in decimals, add them together. I haven't done it, which is what's over on the right hand side. Root 13 plus root 104 equals something, right? You can fill that in yourself. Then get x plus y, which is 12i plus 5j. Get the magnitude of that. That works out as 13, and you should then show that the answer that I haven't filled in is greater than 13. That's question 3 done. Question 4. Now, if you haven't done it, I'd ask you to read it, because honestly I forget whether I gave it to you or not. So here we go. The vector m is 2i minus j. Vector p, should have an arrow over that p by the way, is 4i plus 3j. We're then told that k and l are scalars, and k times the vector m plus l times the vector p equals 2i minus 11j in the question. So I've just set it up. I've taken out the m and put in the vector value there in the second line with writing on it. I've taken out the p vector and put in the I and j components of it. And then in the next line, I'm multiplying by the scalar, because that's what you do. Scalars multiply by the I and the j components. So there's the distribution method of multiplication there. And then if the left equals the right, then the total vector on the left must equal the total vector on the right. So what we can do is we can say the i's on the left have to equal the i's on the right, and the j's on the left have to equal the j's on the right. So I've underlined the I terms. 2ki plus 4li equals 2i. And what I've done then in the next line, I've put that on the left-hand side on its own, got rid of the i's, because if 2ki plus 4li is equal to 2i, then surely 2k plus 4l is equal to 2. I've done the same then with the j's, and then I'm solving simultaneous equations. The equation on the left I divide by 2 because it makes everything easier for me, and I solve for L and K. For you guys, pause the video, do question 8. Okay, I'm going to keep going though. So parallel vectors. Alright, I have an example pair of parallel vectors there. A is the vector 2i plus 3j, and B is the vector 4i plus 6j. And if two vectors are parallel, then either the angle that both of them make with the y-axis is the same, or the simpler way of looking at it is one of them is a scalar multiple of the other. And you can see that immediately there. A, if you multiplied A by 2, you'd get B, so they have to be parallel. Now, sometimes it's not easy to spot because it might be a multiple by a negative number. You might see that it's a multiple of minus 7 over 3 or something ridiculous like that. If that's the case and you can't spot it, you're going to have to go to method 1, which is work out the angle that they make with the y-axis, or the acute angle they make with it. So here's it done out. The left-hand side is the angle method, right-hand side is the scalar multiple method. I'll start with the right-hand side by inspection. We just look at it, we see it. The angle B was twice the angle A, so they're parallel. Job done. The more complicated way, and the way that will always work for you, get the direction of A, so get the inverse tan of 3 over 2, put that into the calculator, making sure your calculator is in degrees. And then for the direction of B, is the inverse tan of 6 over 4, and sure 6 over 4 is an equivalent fraction to 3 over 2. So you get the same angle. As a result then you can say that angle A is parallel to angle B. Okay, pause the video, do 11 and 13 from that handout, and I'm going to keep going. Now, vectors that are perpendicular. So I've got two vectors there, A and B, that are perpendicular. I've even got the right angle between them. Alright, how do you show they're perpendicular? So one of the ways to do it is to find the slope of both lines. So you can say that these vectors have lines that lie in the same direction as them, and if those lines are perpendicular, we know the slope of the first by the slope of the second equals minus 1. Or the slope of one of them is minus 1 over the slope of the other. Now, in terms of vectors, the slope actually equals tan of the angle. This should hopefully make sense. You see? So if we took this vector here, if that was a line and we took the rise over the run is that value and the run is that value. So it's the vertical height over the horizontal height. The tan of the angle then, if that's the angle A, is the opposite, which is the rise, over the adjacent, which is the run. So the slope equals the tan of the angle. So what you could do in this case is you would get the tan of the angle of the first one, the tan of the angle of the second one, and multiply the two of them together. If you do that though, and this is one of those instances where you don't take the positive value to get the acute angles, like I suggested, you would just leave in the negative values there and it will work out as -1. There's another way of doing it that's slightly easier, and it's by inspection as well. So if you have a vector there, xi plus yj, then the perpendicular vector, first off, one of the signs is swapped. So if I've got plus and plus here, one of the signs is swapped. So it's either minus y plus x or y minus x there. Right? And the second thing is the values are swapped around and they may be multiplied by a constant. So if you want to know if they're perpendicular, ask yourself, can you swap around the values in front of the I and the j there, like so? Can you change one of the signs and can you then multiply that vector by some scalar? And if that's the case, will it give you the vector b? And if that's the case, then they are perpendicular. Okay, with that in mind, will you do 7, 12, and 14? And the last one, this is a random question, it's question 9. It says, if the magnitude of that vector equals the magnitude of that vector, find the two values for k. So I've got the magnitude of the vector, square root of 8 squared plus minus 1 squared. Got the magnitude of that vector, 7 squared plus k squared. Simplified it on the left, simplified it on the right, squared both sides, brought that over, I get 16 is equal to k squared. And when you get the square root, then k equals plus or minus 4. You need to factor in both possibilities. All right, and finally, will you do question 10, please, on that handout?